Okay, hello everyone. In today's physics class, we're going to look at the topics of resultant. We're going to look at what we mean by resultant vectors, and we're also going to look at what we mean by components of a resultant vector. So let's begin with the resultant vector. It's an important topic in physics. Okay, so let's jump straight into it. So the resultant vector is a single vector. Resultant vector is that single vector which would have the same effect in magnitude and direction as the original vectors acting together. So just imagine two or more vectors. So these two or more vectors can be combined to a single resultant vector, okay, which will have the same effect in magnitude and direction. Remember, vectors have to have magnitude and direction. Okay, so the methods to find the resultant of vectors, resultant, so when you hear of resultant, think of a single vector to replace two or more vectors. Okay, all right. Let's look at collinear vectors. Basically, collinear vectors are vectors that are at like 180 to each other. That means they are acting in a horizontal. That is the angle between the two vectors. For instance, look at this 8 Newton vector and this 3 Newton vector. Like they're acting like a tug of war on this box. So there's an 8 Newton force going eastward and there's a 3 Newton force going westward. The angle between them is 180 degrees, like that, a semicircle. So they are called collinear vectors. So it's the resultant vector of these two vectors is basically 5 Newton. You can imagine a tug of war. So it will just be you add both of them, but because the 3 Newton is moving in an opposite direction, so it just becomes 8 plus minus 3. So 5 Newton. So this 5 Newton is a resultant vector. The magnitude is 5 and the direction is eastward. So this is a single vector which is the resultant of these two vectors. All right, let's look at this other case. Now these are two vectors again, 2 Newton and 8 Newton force acting on this box. Let's assume this is a box. Now the angle between them is basically 0 degrees. There's no angle between them, right? So it's 0 degrees. Okay, so the resultant of these two vectors is basically like we'll call this vector addition. So because they're in the same direction, there's no they compound, they add up. The compound effect is 10 Newton. So this box will be moved in the eastward direction, that's to the right, by this single force. So this single force, 10 Newton, is the resultant, okay, of these two forces, 2 Newton and 8 Newton. So this is the resultant of these two forces. So this is by resultant, a single vector that represents two or more other vectors. Okay, so this 10 Newton, this is magnitude 10 Newton and direction is eastward. Okay, thank you. All right, now, not for there are cases where the angle, the vectors are not collinear. That means they are not at 180 degrees to each other or 0 degrees to each other. They could be at other angles in between 0 and 180 like that. Okay, so for those cases, we have two ways methods we can use. So methods to find the resultant of non-collinear vectors are we use the triangle method if the vectors are perpendicular to each other. That means they are at 90 degrees to each other. Perpendicular vectors are vectors at 90 degrees. So we apply the triangle method, which is basically Pythagoras theorem. Okay, and then if they are non-perpendicular and of course non-collinear, we use the parallelogram method. It's basically your uses of sine and cosine rules from mathematics. So the cosine rule will give you the magnitude and the sine rule for the direction. For perpendicular vectors, we're going to see an example where we use the Pythagoras for the magnitude and tan theta for the direction. Okay, let's look at this typical example. We have that the question, well, look at this question. An object is acted upon by two forces of 5 Newton and 12 Newton. An object is acted upon by two forces of 5 Newton and 12 Newton. Calculate the resultant of the two forces. So we have three cases. The first case is if the forces act perpendicular to each other. So it looks something like this. This is a 5 Newton. We can use the y-axis to show the 5 Newton force and the x-axis for the 12 Newton force. Now perpendicular, that means they form a right angle. okay, right angle here. So this is the diagram. Now the resultant is simply this hypotenuse side, the hypotenuse of the right angle it forms. Now this broken line here I have is has the same size value as the side. Remember, opposite sides of a rectangle are equal. Okay, so it forms, so you can use that knowledge of your rectangle to form a right angle. So this basically, this will be your 5 units, and this become 12, and then you can apply Pythagoras to find the hypotenuse. Okay, so let's continue. So we've drawn the right angle triangle. Okay, of course, remember right angle is 90 degrees, so I should have just shown my 90 degrees there. Okay, so you can use your knowledge of Pythagoras to find this resultant. So the resultant is usually shown as the hypotenuse side of the right angle triangle. So from Pythagoras, you see that r is equals to that's 5 squared. So this side we're taking this as 5, and this side as 12. Okay. All right, so we have that 169. So the root of 169, which is 13 Newton, gives us, so this 13 Newton gives us the magnitude of the resultant. But the result, a vector must have both magnitude and direction. So the direction of this resultant is taken with respect to the x-axis, that is the horizontal axis. So this theta, see the angle between r and the 12 Newton, or the horizontal x-axis, is this theta. So this theta, you can always use the value here and the value here. Those are the two values you are given, okay? And tan theta will help us there. So the inverse tan of 5 over 12. All right, so tan theta is what connects the adjacent, the opposite and the adjacent. Because it is your angle, this is the opposite side and this is the adjacent. So tan theta is always available for us to use. Okay, it's easier. Okay, so do that. So tan theta is 5 over 12. Okay, so 5 over 12, you get the value. But because we are looking for theta itself, we use inverse tan. Okay, inverse tan of that gives 20.6 degrees. So this is the direction with respect to the x-axis. That's the x-axis. Or you can say 22.6 degrees with respect to the 12 Newton force, if you like. So this is the magnitude, 13 Newton, and this is the direction. Now let's look at the second case. Second case is if the forces were acting at an angle of 40 degrees to each other. Now it's no longer perpendicular. So it looks something like this. This is a 5 Newton force and this is a 12 Newton force. So they are acting at an angle less than 90 degrees or 40 degrees. So this is the diagram. So of course you need the opposite side. So it forms a parallelogram, sort of parallelogram. And also the opposite side of parallelogram also equal, just like rectangle. Okay, so this gives us a diagram of the question. The 5 Newton force and the 12 Newton force, they are no longer at 90 degrees to each other, but less than 90. So this angle shows 40 degrees. So this smaller angle here, this one here, is theta. It will be used to get the direction of the resultant. The resultant is also this single force. Okay, so the theta is for the smaller angle here is for the direction of r later. Now, if this all of this angle here is 40 degrees, you can just look at using your knowledge of corresponding angles. So if this angle is 40, and this line continues as 40, so that means that this angle here, this adjacent angle must be 180 minus 40, which is 140 degrees. Okay, because this line is opposite to this line, and they are all on a straight line. So if this side is 40, this is also 40 on the straight line. That means this must be 140 degrees. Okay, so we have so we can use this triangle. Remember, this side is gotten from the original diagram. Opposite sides of a parallelogram are also equal in length. So this is our resultant. So this is our resultant, right? Okay. So this triangle is we have an obtuse angle here. Okay, an angle greater than 90 degrees. So we can use it. Now use your cosine rule to find the magnitude of r. So this is our C. Okay, so this is like our C and A and B. Okay, so this is A, this is B, this is C. So that's C squared, which is R squared, is equals to A squared plus B squared. Okay, so this is our R is C. So like that, your cosine rule, where cos C is basically the angle cos 140 degrees opposite side C. Okay, so that's cosine rule. So use the knowledge of that, and then if you reduce it together, R is going to give you 16.15 Newton. Okay, so that is our knowledge of cosine rule. So it gives the cosine rule gives us the magnitude of our resultant r. Okay, just visualize this triangle that I'm tracing out. Now, how about this direction with respect to x-axis? So this direction, the direction of r with respect to x-axis, this angle, smaller angle here, theta. Okay, so we can use our knowledge of sine rule. Sine rule is simply going to be, can use r over sine 140 degrees is equals to 5 Newton over sine theta. So any two sides with its angles, its opposite angle, can be used within the sine rule, which is a over sine equals to b over sine b. Remember your sine rule. So our a is going to be r. Our angle a is going to be 140 degrees, like I said, 5 Newton like that, and theta. So just that's just like that and this.